Today we will learn about the trigonometry of right angle triangle with side A, B and C.
Side A is known as the hypotenuse because it is the longest side of the right angle triangle, and also it is the side opposite to the right angle. The side opposite to the right angle is the hypotenuse, so A becomes our hypotenuse. We label it as the hypotenuse. Now, if we are studying the length of sides of a right angle triangle, then there's a need to consider the angles between the sides of a right angle triangle. Assuming we have our angle theta here, then with respect to the angle theta, B becomes the opposite side because it is the side directly opposite to the angle theta, or the side facing the angle theta. So we label B as the opposite, like this. And C is just beside the angle theta, so C becomes the adjacent side. C becomes the adjacent side. Now, we know the three label parts of our right angle triangle. In any right angle triangle, the hypotenuse is the only side which is fixed or known. The other two sides, which is the opposite and the adjacent, depends on the position of the angle we are considering. Assuming we have another angle here, alpha, then here becomes the opposite side to the angle alpha, and here becomes the adjacent side to the angle alpha. Always the opposite and the adjacent is with respect to the angle you are considering. We cannot do trigonometry without learning about the major trigonometry ratios. The major trigonometry ratios are the sine for short. We have the cosine, also cos for short, and then the tangent, also tan for short. These are the three major trigonometry ratios: the sine, cosine, and the tangent. Now, let's look at the definitions or the formula for these three trigonometric ratios. The sine of an angle, here the sine of the angle theta, the sine of the angle theta is always equal to the opposite side over the hypotenuse. Opposite over the hypotenuse. Very good. O for opposite, and then H for hypotenuse. Also, the cosine or cos of an angle, cos of the angle theta, is always equal to the adjacent side over the hypotenuse. So cos theta is equal to adjacent over the hypotenuse. Over the hypotenuse, A for adjacent and H for hypotenuse. And then the tangent of an angle or tan of an angle. The tan of an angle, this angle theta, is always equal to the opposite side over the adjacent side, O for opposite, over the adjacent, A over the adjacent side, A for adjacent. These are the three trigonometry ratios to have in mind. You should always remember how the trigonometry ratios relate to the sides of the right angle triangle. Sine is the opposite over the hypotenuse. Cos is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. Here is a simple acronym to learn or memorize these trigonometry ratios, because sine can be represented by S, which is equal to the opposite O over the hypotenuse H. So I write my O and then H for hypotenuse. And then we move to cos. Cos is C, is equal to adjacent, which is A, over the hypotenuse H. And then tan, T for tan, equal to opposite O over the adjacent A. We call this SOHCAHTOA. SOHCAHTOA. This is an acronym to remember the trigonometric ratios. Now, anytime we know the value of the trigonometric ratio, we can go ahead and find the value of the angle theta here. Now, we already know that sine theta is equal to O over H, which is opposite over hypotenuse. To find the value of the angle theta, I said earlier that anytime you know the value of the trigonometric ratio, assuming O over H is a number, we can find the angle theta by finding the sine inverse of the ratio. So theta is equal to the sine inverse of O over H. We can do same for cos. We know that cos of the angle theta is always equal to, cos theta is equal to adjacent over the hypotenuse, A over H. Now, our theta becomes the cos inverse of the ratio A over H. This is the theta value for angle theta. Now, let's do same for tan. Tan theta is equal to O over A. Then the angle theta will be equal to the tan inverse of O over A. We can always find the angle if we know the trigonometric ratio. Let's look at example 1. If you are new to the channel, kindly subscribe, like and share the video for someone else to enjoy the lessons. Kindly put in any question you have in the comment section and it will be addressed. Thank you. Example 1. We are to find the value of theta in each of the following figures. We have our figure 1 and 2 here. We are supposed to find the value of theta in the right bottom corner here. To find theta, we need to choose the appropriate trigonometric ratio. Remember that the longest side or the side directly opposite to the right angle is the hypotenuse. So here is our hypotenuse. Now, if we know our hypotenuse, then let's look for the other two sides. The side directly opposite to the angle is known as the opposite, and the side beside the angle is known as the adjacent side. So here 4 is opposite to the angle, and 4 becomes the opposite side, and 3 becomes our adjacent. Now, from our acronym SOHCAHTOA, the trigonometric ratio that relates the adjacent side to the opposite side is tan. Tan relates opposite to the adjacent. So tan will be the appropriate ratio to use here. We now have tan of the angle theta is equal to the opposite, which is 4, over the adjacent, which is now 3. Remember that to find the value of the angle theta, we need to find the tan inverse of the trigonometry ratio. Our theta now becomes the tan inverse of 4 over 3. Solving this on the calculator, our theta will be equal to tan inverse of 4 over 3 on the calculator is 53.1 degrees. This is the value of the angle theta. In the second diagram, theta is in the top left corner, and this is the right angle. Because theta is in the top left corner, the side opposite to theta, 13, now becomes our opposite side. And the side opposite to the right angle is the hypotenuse. The hypotenuse is always the side opposite to the right angle. So 15 is the hypotenuse, H. Please pay attention here. Now, from SOHCAHTOA, the trigonometric ratio that relates the opposite side to the hypotenuse side is sine. Sine is the one that relates O and H. So from here, sine of the angle theta will be equal to the opposite side, which is 13, over the hypotenuse, which is now 15. To find the angle theta, we know that we will find the sine inverse of the ratio, which is 13 over 15. Theta will now be equal to, solving the sine inverse of 13 over 15 will give 60.1 degrees as the answer. Let's look at the second example. Pause this video and solve on your own. Compare your answer later. We are to find the value of theta here. This is the right angle. 17 is opposite to the right angle. And because of that, 17 is the hypotenuse, H. This side is opposite to the angle theta, so here is O, opposite, and 8 is beside the angle theta, so is A, the adjacent side. Now, from SOHCAHTOA, which trigonometry ratio relates the adjacent to the hypotenuse? We realize that cos relates the adjacent to the hypotenuse, so we will use cos. Now we have cos of the angle theta is equal to the adjacent, which is 8, over the hypotenuse, which is 17. To find the angle theta, we go ahead and find the cos inverse of 8 over 17. Solving this on the calculator, our theta now becomes cos inverse of 8 over 17 from the calculator is 61.9 degrees. So the value of theta is now 61.9 degrees.
In the next video, we will solve practical application questions in trigonometry. Subscribe and stay tuned.